Right, so they've given you this formula. The distance you can see is 3.56 times the square root of the height. And the unusual thing here is that the height is measured in meters, but the distance that you can see is measured in kilometers. And then they've said, okay, how far would you be able to see if you were in an aeroplane at a height of 10,000 meters above sea level? So what you do is you just put this formula directly into there, that the distance in kilometers would be 3.56 times the height the square root of the height that I'm at, which is 10,000 kilometers. Using our skills of surds, we know that 100,000 is the same as the square root of 100 times 100. Here we've got identical numbers. Square root of 100 times square root of 100. So the answer is going to be 3.56 times 100. So we haven't had to use our calculator at all. And the distance that we'll be able to see is 3.56 times 100, 356 kilometers. So when we're in an aeroplane at 10,000 meters height and we look on the horizon we can see on a really clear day 356 kilometers away. And then the next question was, well, how high could you see if you were at the top of the Eiffel Tower, which was 300 meters? Again, we use the formula that D is 3.56 times the square root of h, which in this case is 3.56 times the square root of 300. The square root of 300 is 17.3. So we get 3.56 times 17.3, giving us 61.7 kilometers, which we would round off to whole kilometers. I mean, it's not an exact science here. 62 kilometers. 2 0 decimals. So if we were at the top of the Eiffel Tower, we could see 62 kilometers to the horizon. And if we were at the top, flying in an aeroplane at 10,000 meters high, we'd be able to see 356 kilometers. And the unusual thing here was that we've got different units. They've given us a formula with different units, so keep them in those units. Okay?